Now that we know how to find volumes of prisms and cylinders, let's actually apply that. Let's find some volumes of prisms and cylinders. So part A, Lanzel needs to store 20 feet cubed. So this cubed right here indicates a volume measurement. If that was squared, that would be an area measurement. So we're looking for a volume of 20 feet cubed of firewood. Could he use the storage rack shown? So here's a storage rack. We can see it's 6 feet long this way, 2 feet deep. From the top to the bottom, that is 4 feet. This is a prism right here. But it's not a, when you can determine that it's a prism, you have to identify where the two bases are. You need to have two bases that are the same size and shape and parallel to each other. So it might be easy to think that the base is here on the bottom. I can see there's a rectangular shape hitting the ground down here, but we don't have a rectangular shape up here that's the same size and parallel to it. So this is not a rectangular prism. What we actually have is a triangle in front and the same triangle in the back. You know, it's a three-dimensional shape, so we can't see that, but we can picture it. So this is a triangular prism, which means that the base is a triangle. That's our key information. So let's find the volume of this prism and see if he can fit 20 feet cubed of firewood in it. So volume of a prism has a formula, area of the base times height. Well, we said that the base is a triangle, so the area of a triangle is 1/2 base times height. So if I were to just draw out the triangle we're working with, we have 6 feet, and then here's this 4 feet. That's our base and that's our height. So the area of our base is 1/2 times 6 times 4. Half of 6 is 3. 3 times 4 is 12. So the area of our triangular base is 12. So that's going to be the area of our base right here. So volume equals area of the base is 12 times now the height. This is not the height. The height is not always an up and down vertical measurement. The height is what connects your two bases. So if we have a triangular base, we need to connect it to the other triangular base. So this 2 feet right here is actually the height of this prism. If we were to take this prism and flop it down so the triangle is on the bottom, it'd be a little bit more clear to see the height of it. But that height is 2. So that's the height of the prism. So it gets a little tricky. We had a height right here, but that's when we were finding the area of the base. This is the height of your base. This height, when we're finding volume, is the height of the prism. So let's just be very careful. All right, so the height is 2. So our volume, 12 times 2, is 24. And we are in feet cubed. So that's the volume that this storage rack can hold. Lanzel just needs 20 feet cubed, and he's got 24 feet cubed here. So can he use the storage rack? He sure can. It definitely will fit. All right, so next question. How would the volume of the storage shed change? So how would this 24 feet cubed change if the length of the triangular base is reduced by half? So our triangular base, the length of it right now is 6 feet. This is the triangular, this is the base of our triangle. If that is reduced by half, so that would then become a 3. Well, what would happen to the area of the base? 3 times 4 is 12. 12 times a half is 6. So now the area of the base would be 6. And if we take the area of the base times the height, so 6 times 2 would give us 12. So the volume would be 12 feet cubed if we took this 6 and reduced it by half to get 3. Well, the volume was 24. When we do that, the volume is 12, so the volume would be reduced by half. Okay, so we just worked with a prism. Now let's work with a cylinder. So Kesha is deciding between the two canisters shown, which canister holds more. So this is a volume question. We want to figure out which canister would have the greater volume. Then what is the volume of the larger canister? Well, let's just find the volume of each one. So volume of a cylinder is area of the base times height, just like a prism. But we know because this is a circular shape, the area of the base is going to be pi r squared times the height of the cylinder. So if we look at this first one, we are given a diameter measurement of 20 centimeters, which means the radius is 10 centimeters. And the height, we've got this height measurement, 25, which applies to both cylinders or canisters. So the height is 25. So we have pi times our radius is 10 squared times a height of 25. If we calculate that out, we get about 7,854 centimeters cubed. So that is the volume for the first canister. All right, now the second canister is not what we would call a right cylinder, where, the center of the base connected to the center of the base is perpendicular. This is an oblique cylinder. So an oblique cylinder is a cylinder that the segment joining the center of the bases is not perpendicular to the planes of the bases. But it is still a cylinder, so we will use the same volume formula. So volume equals anything with two bases that are the same size and parallel to each other is area of the base times height, but these bases are circles, so the area of the base is pi r squared times the height. All right, so if we look at the circular base, the diameter is 20, which means our radius is 10. So pi times our radius 10 squared. And then that height measurement. So the height isn't, I said with the prisms, it's what connects one base to the other. But if you have an oblique cylinder, an oblique prism, the height does have to be perpendicular to the bases. So if this is a base and this is a base, we have to find that perpendicular length that connects it. So in this case, the height is 25, not this 27 over here. They told us this 27 to be tricky and throw us off, but the height is a perpendicular measurement to the plane that has the base. So this one has a height of 25. Well, there's that same math. Pi times 10 squared times 25. This is a 7,854 centimeters cubed volume. So what did we figure out? Both canisters have the same volume. So it doesn't matter which canister Kesha chooses. So we have one more question. How would the volume of the canister change if the diameter is doubled? Well, our diameter was 20, right? So if we double that to a diameter of 40, how would the volume change? Well, we can quick calculate that. The volume was equal to pi times, now our radius would be half of the diameter, so 20 squared, times our height was 25. That gets us about 31,416. So it got a lot bigger. It went from the 7,854 all the way up to 31,416. So how much did that increase by? Well, we can just quickly divide that out. If we take our 31,416, divide by 7,854, that gives us 4. So that means that the volume got multiplied by 4 to give us our new volume when all we did was double the diameter. So the volume increases by a factor of 4.